Hi guys, welcome to Spare Minute for Chemistry with NB. So guys, today we are going to learn about chemical equilibrium. Chemical equilibrium is a state in which the rates of forward and reverse reaction becomes equal in a reversible reaction. In chemistry, a reversible reaction is a reaction in which the reactants can react together to form the products, whereas the products react together to give back the original reactants. A reversible reaction is always represented by an arrow, which is used for the representation of a reversible reaction in which a half arrow is being pointed towards the forward side and half is pointed towards the backward direction, indicating that it is a reversible reaction. Like this reaction shows, A and B are reacting together, reversibly producing the product C and D are again reacting together to form the original reactants A and B. Consider the example of a reactant A and B reacting together, and after collision they will form the product A and B. Again, the product A and B simultaneously is converting back into the original reactants A and B. So it is a form of a reversible reaction. Chemical equilibrium is only achieved when the moles of the reactants becomes equal to the moles of the product. So the rate of forward and reverse reaction becomes equal. The reaction won't stop at this stage but only attain equilibrium, so we can say that it's dynamic in nature. Hence, in chemistry, the chemical equilibrium is always dynamic in nature. So this is the reason for its diversity and dynamic nature, that the rates of forward and reverse reactions are equal, so it is a dynamic equilibrium. So the main key points are the reaction occurrence, the conversion of reactant into products, and the product conversion back into the original reactant, and their concentration become equal. Now we'll study about the importance of chemical equilibrium, that why it's important in chemistry. The main importance is the dynamic equilibrium helps us to understand the reactions and their feasibility and the stability of a reaction. And as far as the biological reactions are concerned, which are enzyme catalyzed, they will also involve the chemical equilibrium. Consider the example of the formation of hydrogen iodide, in which hydrogen and iodine react together to form hydrogen iodide, and hydrogen iodide in turn in the reverse reaction will form the original reactant, which is hydrogen and iodine. The reactions shown on the screen gives us the forward reaction in which H and I2 reacting together to form Hi, which is hydrogen iodide, and in reverse reaction the hydrogen and iodine are being produced by the hydrogen iodide. The dynamic equilibrium also exists between the formation of sulfur trioxide, which is formed by the reaction between sulfur dioxide, represented by SO2, and oxygen, represented by O2. The graphical description for the formation of SO3 will be shared with you on the screen, and it is called as the concentration time graph, in which you can see the difference between the initial and the final concentrations. The reversible reaction on a graphical scale is represented with the help of a concentration time graph. Here is the concentration time graph for the formation of hydrogen iodide, which shows the reverse and the forward reaction simultaneously. The concentration time graph of the formation of SO3 is being shown, and it shows clearly that the concentration of reactants is initially higher and it starts to decrease, while the concentration of product is low in the start and it starts to increase till a point is reached, which is known as the equivalent point, and then we have the dynamic equilibrium established between the reactants and the products. So here is a general description: the initial concentrations and the final concentrations. At some point the level become equal and we will attain the chemical equilibrium. The general key points of the graph are the initial stage, the equilibrium point stage, and then the occurrence of the dynamic equilibrium, in which the forward and reverse reaction becomes equal. So generally we can summarize the reaction as the reaction progress. We can guess this from the graph, the equilibrium constant, and the stability of a reaction with the help of a concentration time graph. Equilibrium constant, also known as the Kc of a reaction, is the ratio of the concentration of the product to the product of the concentration of the reactants, and it shows us the stability of a chemical reaction. We are going to study the importance of Kc in detail in our higher classes. So here is the general conclusion of the whole article, in which we study about the graphical explanation and the dynamic equilibrium. So that's all for today. Thanks for tuning in.